Alright, in this worksheet, I'm going to talk about electron configuration and reactivity worksheet. So in this worksheet, there are different kinds of questions I would like to go over. Some of them, they will be comparing which one's more reactive or which one is less reactive, or even compare with noble gas with a metal or noble gas with non-metal. So the first part would be we just use the electron configuration to compare. We are not going to talk about noble gas or we are not going to talk about group like a family name or metal or non-metal. We don't even say anything about that. We just use simply electron configuration compare which one's more reactive than the other. And then we got to use the trend to double check your answer. Okay, so let's see. The first one question is which one is more reactive, F or Cl? So we write down the F atomic number and the electron configuration, and Cl the atomic number electron configuration. And for electron configuration comparison, we have four things to compare all the time. Compare the period, group number, how many valence electron, and how many they gain or how many they lose or they don't gain or lose at all. So F, okay, is period 2. Group is 17 because 2s2, 2p5, right? F is a group 17. So 7 valence electron, he want to gain 1. And Cl is period 3 and group 17 because s2, p5. And they have also 7 valence electron, they want to gain 1. Now here we get 4 different steps. So the first step is we want to talk about what is similar. Now in order for us to say that, we have to use the word both because they do have something similar. All right, so what is similar? Both F and Cl are in group 17. They have 7 valence electron and they need to gain 1 electron. Right, those are the things that they're similar. The next thing is what is different. So when you talk about something different, when you say the word both before, you have to say the word but. Okay, so if you have both, you have to write the word but. If you don't have both, you don't write the word but. Now what is different? But F has 2 periods and Cl has 3 periods. Okay, now the next step is you're going to talk about which is more easier or less easier to gain or lose electron than, with the reason. Now here you're looking for more reactive. That means more easier to do what? Or more easier to gain electron. Now which one is more easier to gain electron? Now they both want to gain 1 electron. So how many electrons they gain is not a matter. What matter is the period. Okay, so which one is more easier to gain electron? Obviously will be F. So you write down F is more easier to gain electron than Cl. Why? Because F is closer to nucleus based on the fact that it's only 2 periods. And Cl is going to be further from the nucleus, which is period 3. So when F is closer to nucleus, which is period 2, definitely will be more easier for fluorine to gain electron because F is closer, will be more attraction. So because of this, step D, you can conclude back to what we write, which is more reactive. Okay, F is more reactive than Cl. More easier, more reactive. So there will be 4 steps. Now, you may choose your answer wrong, so you gotta use the reactivity trend to double check your answer. Now, this is non-metal. So first is non-metal, right? This non-metal. We gotta draw the trend because non-metal is on the right-hand side, so the bigger arrow will be on the right-hand side too. We draw the arrow, we label S and big, right? Small and big, and then we put the element's position. F is on top of Cl. Now, we write down more reactive, okay? So we write down more reactive. Since we write down with more reactive, we want to start with big to small. More meaning big. With the symbol, big mouth always facing to the big. So more reactive meaning from big to small. So how do I write this? Oh, since big to small, we start with the F first because F is near to big. So F greater than Cl. We box that. Now, if I change this to be a sentence, it means that F is more reactive than Cl, which is exactly the conclusion that we come up with step D. So it match. We put a check mark. That means my choice is correct. F is more reactive than Cl. We gotta go to the next question. Which one is less reactive, Li or Na? So we use the electron configuration to figure out. So we first write down the Li, atomic number, Ec, and then the Na, atomic number, Ec. And again, we compare 4 things. We compare period, group, valence electron, they gain how many or lose how many. So we include all the information down, right? 2 period, one group and one valence electron, they want to lose one. And it's a 3 period, group 1, one valence electron and lose 1 electron. Now, do they have anything similar? Yes, they do have something similar. So we have to use the word both. Now, both Li and Na are in group 1, have 1 valence electron, and need to gain need to lose 1 electron. Right? So we write down this word similar. But it has something different. What different? Li has 2 period and Na has 3 period. So then now the question is less reactive. That means we're looking for less easier to lose electron. Now, which one's less easier to lose electron? Which one's less easier to lose electron? Okay, so definitely will be Li. Li is less easier to lose electron than Na. Because Li has only 2 periods, it's closer to the nucleus. And Na has 3 periods, which is farther away. Now, if you want to lose electron, then Li closer to the nucleus must have like a lot of attraction. Then it will be less easier for Li to be lost. But Na is further away, so it will be easier for Na to lose. So in this case, Li is less easier to lose electron than Na because Li is closer. So then we can change the sentence to be Li is less reactive than Na. We use less easier, less reactive. So Li is less easier than Na. Now we're going to use the trend to double check. Now first of all, this is metal reactivity, right? Metal reactivity, and metal are on the left hand side. So we draw the trend, the big side on the left, arrow on the left, small on the right. We arrange them, Li is on the top and A. And then now we write a less reactive. That's the question, less reactive. So we write less reactive dot dot. Now less reactive meaning which one is smaller first. So we write smaller, bigger than smaller, smaller to bigger with the symbol, the mouth facing to the big. Okay, so S smaller than big. Then now we arrange, okay, we start with the smaller first. Which one smaller? Li, because Li is closer to S. So Li smaller than Na. If we change the sentence, if you change the symbol to the sentence, then will be Li is less reactive than Na, which is exactly what we conclude here. So then that's why I put a check mark on it. Okay. On the back. Now, number 3, which one is less reactive, Ar and K? Now, Ar is a noble gas. Okay, so we first do the same thing. We write down electron configuration. We write down the period, group number, valence electron. Now, the argon does not gain or lose electron. But we did not talk about family. We did not talk about noble gas. We just use electron configuration. They did not gain, they did not lose. Now A, we're supposed to write something was similar, but here you look it up, nothing is similar between Ar and K. So nothing is similar between Ar and K. We don't use the word both because we don't have anything similar. Now because we don't use the word both, we don't use the word but. So part B, everything is different. Everything is different. Nothing is similar. Everything is different. And step C, you want to talk about, again, right, which one is less easier to gain or lose than the other. Now here, which one is less easier to lose electron? Because K is talking about lose electron, so we want to compare lose electron. Which one is less easier to lose electron? Obvious is Ar. Ar is less easier to lose electron than K because Ar did not even gain or lose anything, but K still lose 1 electron. So then step D, we can convert into like reactive, is Ar is less reactive than K based on the step C. Now, because Ar is the noble gas, no matter reactivity, we do not include noble gas at all. So we would not have any trend. So we would just write no reactivity trend can be used, but noble gas is always non-reactive. Now here we can use noble gas because we already done with the electron configuration. We just use the trend to explain. Okay, noble gas is always non-reactive. Now number 4, which one is more reactive, Na or Al? So again, we write down the Na, write down the Al, is electron configuration, and the period, group, valence electron, and lose electron. All right, so do they have anything in similar? Yes, they do. Both Na and Li have 3 period and need to lose electron. Now you see period 3, they both have the same thing, and lose electron, they do have the same thing. Now some people said that why need to write need to lose electron? Because they do both do the same job. They both lose electron, but one lose only 1, one lose 3. That would be different. So we do still have to say they both lose electron. That's what they're similar. Now part B, but there's something different. What's different? Na is on group 1, has 1 valence electron and needs to lose 1. Li is in group 13, has 3 valence electron, now want to lose 3. That will be something different. So then now the question is more reactive, then we're looking for which one is more easier to lose electron. Now which is more easier? Obviously will be Na. Na is more easier to lose electron than Al. Oh, why? Because Na only need to lose 1, but Al need to lose 3. So Na losing 1 electron is more easier than to lose electron than Al. Then in this case we can change that to reactivity. Na is more reactive than Al. So then we can use the trend to double check. Now this is metal reactivity. So we draw the trend. Metal is on the left hand side, so we put the big arrow and the big on the left, small on the right. We arrange Na and Al. Now the question is more reactive. So we write more reactive means we start with the big one. Start with the big one and then arrows the small one. So we should start with Na because N is near to the big. Okay, so Na greater than Al. Al sounds small. So if I change this to be a sentence, it will be Na is more reactive than Al, which is matching with my part D answer. So I'm okay. So that's why I put a check mark on it.